second variant, okay, in the second variant, this does only partial processing. That is, it does not process any imperative statements at all, okay, except if it is a literal, okay. Now it only processes an assembler directives or declaration statements. This is necessary because I need to do location counter processing. If I want to do location counter processing, then it is very essential in pass 1 I do processing of assembler directives, we do processing of a declaration statement, and we do only the literal processing in variant 2. So if you look at this particular example, the first statement is similar to variant 1 because it happens to be an assembler directive, but the second statement, which happens to be an imperative statement, we have written the symbol A as it is. Similarly for move on. So that is partial processing is done. Except when it is a literal, I am writing that class of the literal is L and we are writing the entry of the literal in the literal table. This is done basically because location counter processing should take place. Okay, if it has to take place, then I have to process the literals, I have to process assembler directives, and I have to process declaration statements. Okay, so what is the difference between variant 1 and variant 2? Okay, so if you look at the intermediate code of variant 1, we see that pass 1 does most of the processing. Okay, all that is required of pass 2 is simply take the intermediate code that is present there and get the associated addresses. Okay, now if it encounters a literal, all it has to do is refer the literal table and it would obtain all the associated addresses. If it is a symbol, the associated address would be found into the symbol table. So most of the work is done by pass 1, whereas if you look at pass 2, it does a very minimum amount of work as compared to pass 1 in variant 1. Okay, now your intermediate codes that is being created is compact. Okay, how it is compact is this particular representation, okay, C comma 200 or S comma 01, the number of bits used to represent this particular field, okay, is as equal to the number of bits that are used to represent the address associated with memory words. So that is why your instruction code that is created by variant 1 is very compact. Now if you look at variant 2, pass 1's work is reduced. That is, we do not do processing of imperative statement. All that work that is done by pass 1 or majority of the work is transferred to pass 2, and as comparatively my intermediate code, which was compact in variant 1, would be less compact. Okay, but if you look at the way functioning of pass 1 and pass 2 takes place, then these two passes would be equally balanced, whether it is the work done by two passes, the functions that are done by the two passes, or the memory that is occupied by the two passes. So looking at the memory requirements of the two variants, looking at the memory requirements required by the two variants, you will see that in variant 1, pass 1 has more memory requirement than pass 2, whereas when you look at variant 2, the memory requirement done by pass 1 and pass 2 are of same size. Okay, so this is the comparison of these particular two variants in terms of memory space. Where would we wish to have variant 2 instead of variant 1? This is such an example where it is preferred we have the second variant form of intermediate code rather than the first variant form. See, if you look at this particular statement, okay, you will have an intermediate code of the form IS. Its instruction opcode will be 05. If you look at BRG, it is the second register, so you will write 02. Now if you look at this, okay, so what is this? This is basically a symbol. You have to find the entry number of area within the symbol table. So it's suppose say the entry number is 02. Now this statement would be written like this. Okay, so processing of this particular field by pass 2 would be a complex task. It would be a difficult task. So it is better we have not processed this particular statement at all, in which case the variant 2 would be more useful. Okay, so it is statements like these where we would prefer that we had variant 2 form, intermediate code in variant 2 form, rather than having an intermediate code in variant 1 form. This is not good when you compare it as requirement for memory also. It is not good when you compare it in terms of processing of the statement also. So this is where variant 2 has an edge over variant 1. So these type of statements, it is preferred that we have variant 2 form rather than we have a variant 1 form. Now we stick to the variant 1 form, okay, rather than looking, we do not take in the variant 2 form to represent an intermediate code. So in that variant 1 form, we are going to address certain issues, that is, how do I process all the assembler directives and declaration statements that occur in my program? What do I do with the TC statement, which is a part of the declaration statement? What do we do when we encounter start and origin? And what about the literal organization or LTORG statement is encountered? Now, the question was, what do we do or how to process the assembler directives and the declaration statements? Okay. Now, if you look at this particular piece of assembly program, we will see that we have an assembler directive and we have declaration statements. Okay. Now, in the intermediate code form that has been written over here, that has been generated for these statements in the assembly program, okay, we have associated the address. Okay, now the question is, if I associate the address, do I require an intermediate code for the assembler directive start and declaration statement DS? Okay, and this question can be answered by looking at this particular program and the corresponding intermediate code that has been generated. Now, if you look at this program, you will see that whenever if the addresses are associated with the intermediate code for this particular assembly program, we see that the address for this declaration statement DC could be directly informed, okay, could be directly inferred, because this would obviously say that start at location 101. That means the target program should occupy place from location 101. So obviously the statement DS would be at location 101. Now DS is basically a statement which says that it occupies one memory word. So the next statement would be at location 102. So if addresses are associated in the intermediate code, then I do not need to write an intermediate code for assembly directives, and I do not need to write an intermediate code for declaration statements of the form DS. Okay, but I do require an intermediate code form for DC. It is essential because I need to do LC processing. But this particular example shows that for an assembler directive and for a declarative statement of DS type, we do not have to write the intermediate code if the address is associated with the intermediate code. Okay, if at all we do not associate the address, then for pass-through, to get the associated address, we would require the intermediate code. So if we put the address, we do not write the intermediate code form. If we do not put the address, then we have to write the intermediate code form of the assembler directives and declaration statement. Okay. The next question was whether for start, okay, and for origin, do I need to write an intermediate code form? It is not essential because they are basically doing one job. Start and origin are assembler directives that are basically setting the location counter value, or they are basically changing the value of the location counter. So it is not essential key I have an intermediate code form written for the assembler directives start and origin. Okay. Now when it comes to LTORG and I need to generate an intermediate code form, okay, there are two ways to do this. Okay, one, you can make pass1 do the entire processing, that is associating values with the literals can also be done in pass1, or you can simply transfer that control to that job or that function to pass-through. Now when you are going to transfer the job of associating addresses to literals to pass2, all you are going to write is, okay, you are going to write it as an assembler directive and 05. So if you write such a statement, okay, it becomes the job of pass2 to associate the address values with the literals that have been encountered in the program so far. Okay, now since literals are treated to statements of DC form, which we studied in the previous class, in the intermediate code form we do not write assembler directive, we write them as declaration statements, and it happens to be DC is 0, 1, and that is why for LTORG the intermediate code is DL, 01, because all literals in our program are treated to be equivalent, are treated of the form like this way. For example, if I have a literal, say add BREG, and we said 5, we've already done this. We said that the assembler would treat this particular statement as add BREG. It would give a symbol name to a memory operand, and in that memory operand, okay, it would associate the value 5. Okay, so that is why when we encounter LTORG statement, we are treating it to be a declaration statement and its associated code as 1, because for DC it is 1. Now when we are, this is one form wherein I am allowing where I am making pass to do the get the associated values with the literals. Now there is another form wherein you can ask pass1, okay, you can write an intermediate code form, okay, wherein pass1 is going to do the processing of the literal, that is pass1 is going to get the values or the address associated with the literals. In that case, the intermediate code form for LTORG would be a series of DL statements, okay, and would be of the form like this. Suppose we have encountered a literal 5 in our program, say add BREG, okay, and you have encountered a literal 5, okay. Now for this literal 5, when we encounter LTORG statement, I have encountered only one literal, so I will write DL01 and I will write constant 05. And if you have encountered more, you will have to write a series of DL units. So this is how the intermediate code form for LTORG will be written. And if you write it in this form, it basically means that pass1 is doing more work and pass2 is doing comparatively less work.